Okay students, so now let us go for multi-nominal theorem. Clear? So as you all know, the expansion of binomial theorem is a plus b, that is a plus b whole to the power of n is equal to nc0 a to the power of n b to the power of 0. Clear? Plus nc1 a to the power of n minus 1 b to the power of 1. Next, plus nc2 a to the power of n minus 2 b to the power of 2. Clear? Plus so on to plus ncn a to the power of 0 b to the power of n. Clear? So you all know the expansion of binomial theorem is written like this. Clear? Or we all know the formula of binomial expansion. Clear? So now let us go for multi-nominal theorem and the application of multi-nominal theorem. Clear? So multi-nominal theorem means the variables or the elements more than 2. Clear? Here there are only 2 elements. So whenever you are having more than 2, that means 3 or more. Clear? 3 means trinomial. Clear? So therefore if you use 3 or more, 4 or more, 5 or more, clear? Like that, if the terms in the expansion are, that means the term in the expansion are more than 3, clear? Then we call it as multi-nominal. Clear? Then we call it as multi-nominal. Clear? Okay. Directly we shall go for the applications of multi-nominal theorem. Clear? Let us consider you have 4 objects. You have 4 objects and these 4 objects are distributed. These 4 objects are distributed for 3 persons. For 3 persons. Clear? 4 objects are distributed for 3 persons. Then let us check what are the possibilities. Clear? So possibilities of P1, P2, P3 or possibilities of person X, person Y and person Z. Clear? So for that let us take X, Y and Z. Clear? So for these 3 people you are distributing 4 objects. Are you getting my point? Here you are distributing 4 objects to 3 people so that anyone can get any type of elements. That means he can get 0, he can get 1, he can get 2, he can get 3 or he can get all 4. Are you getting my point? So listen here, you have 4 objects and you are distributing among 3 people so that all 3 persons can get any number of elements. Again listen here, all 3 persons can get any number of objects. Are you getting my point? So that means, see here, X can get 0, Y can get 0, then Z will get how much? 4. Clear? Because anyone can get any number of elements out of this 4. Clear? So X will be 0, Y will get 1, then Z will get what? 3. X is 0, Y will get 2, Z will get 2. Clear? X is 0, Y will get 3, Z will get 1. Are you getting my point? X is 0, Y will get 4, that means Z is also again 0 because 4 objects has to be distributed among 3 people. 4 objects has to be distributed among 3 persons so that I am checking the possibilities. Clear? So now if again X, Y, Z, if X get 1, see, if X get 1, let us take Y is 0, Z will get how much? 3. Clear? This is also one of the possibility. X get 1, Y get 3, then Z will get 0. Clear? Next, X get 1, Y can get 2, 3 are over, then Z will get 1. Clear? X will get 1, y will get 1, z will get what? 2. Are you getting my point? So that if x is 1, y is 0, z is 3. Like this you are getting the possibilities here. Clear? Now let us go for again x, y, z. See here. Now if x get 2, y can get 1, z can get 1. Are you getting my point? Next, if x get 2, y can get 0, z will get 2. Clear? So therefore, check the possibilities how much you are going to have. Again, if x get 3, y can get 1, z will get 0. If x get 3, y can get 0, z can get 1. Clear? Lastly, x can get 4, y will get 0, z will get 0. Clear? So now let us check the possibilities. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. Clear? So these many possibilities x, y, z are going to have. Let us check one more time. Clear? See again here x can get 2, y can get 2, z will get 0. See x can get 2, y can get 2, z can also get 0. Therefore 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So total 15 possibilities are possible to distribute 4 objects to 3 people. Are you getting my point? Here I am distributing 4 objects among 3 people. So total how many possibilities are there? Here total you have 15 possibilities. Clear? So total you have 15 possibilities of distributing the objects for 3 people. Are you getting my point? So like that we are distributing so that these 15 possible cases are possible here. Check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. Clear? So total 15 possibilities of distributing 4 objects for 3 persons. So this is how multi-nominal theorem is going to be applied. Clear? So now you got 15 possibilities. So every time we can't do this checking of possibilities. So then how we can simplify? That is also important. So let us check here. See, person X has the possibility of 0, possibility of 1, possibility of 2, possibility of 3 and possibility of 4. Clear? So person X has 4 possibilities. Clear? He can get 0 elements, he can get 1 element, he can get 2 element, he can get 3 element, he can get all 4 elements. That means objects. Clear? Okay. So now you got to know a person X can have 4 possibilities. Let us check what about the possibilities of Y. See here, P0 plus P1, P2, P3 and P4. These are the possibilities of X. Again for Y, how many? So this is 1 of X. Next let us go for Y. Again Y has P to the power of 0, P to the power of 1, P to the power of 2, P to the power of 3 plus P to the power of 4. Again Y also has 4 possibilities. Clear? Again it is same for Z. What is Z? Again P to the power of 0, P to the power of 1, P to the power of 2, P to the power of 3 and P to the power of 4. See, X has this many possibilities, Y has again the same possibilities, Z has again the same possibilities. Are you getting my point? So that means we shall solve this theorem by the expansion of multi-nominal. The expansion of multi-nominal. How you are going to expand this multi-nominal? See here, I will multiply all this. I will multiply all this because here AND operation we are using. Clear? If we are using AND operation, we are multiplying all 3 possibilities of X possibilities of y, possibilities of z. If I multiply all these three, it is going to be what? P to the power of 0 plus P to the power of 1 plus P to the power of 2 plus P to the power of 3 plus P to the power of 4 whole to the power of 3. Are you getting my point? So these are the possibilities of all x, y and z. If I multiply all these three, it will be in the form of like this. Now coefficient p to the power of 4 n, this term will give you the total number of possibilities. The total number of possibilities here, coefficient p to the power of 4 in this expansion will give you the total number of possibilities. Have you got my point? So if you want to calculate total number of the possibilities, you have to check what is the coefficient of p to the power of 4 in this expansion. Clear, students? So if I calculate this sum, clear? So if I calculate this sum, what you are going to have, that is 1 divided by 1 minus p whole to the power of 3. 1 divided by 1 minus p whole to the power of 3. So this is equal to what? 1 minus p whole to the power of minus 3. That means coefficient of p to the power of 4 in 1 minus p to the power of minus 3 will give you the total number of possibilities of this particular problem. Clear? So you also must know the expansion of 1 minus x whole to the power of minus n. That is equal to 1 plus nc1x plus n plus 1c2x square plus, clear, n plus 2c3x cube plus so on. So the formula of 1 minus x whole to the power of minus n will be like this, because to express this expansion you must know this formula. Clear? So use this formula here. What you are going to have, 1 minus p whole to the power of minus 3 is equal to 1 plus, next 3c1p plus 3c2p square plus 3c3p to the power of 3. Next, sorry, not 3, after 3 you are going to have 4 plus 1, 5. Clear? Because this is n plus 1, n plus 2, so on. Clear? So 5c3p3. Next, plus 6c3p4. 6c4p to the power of 4. See, we need coefficient of p to the power of 4. What we need? Coefficient of p to the power of 4. What is coefficient of p to the power of 4? 6c4. What is coefficient of p to the power of 4? 6p4. So what is 6p4? 6p4 is equal to 6c4, that is equal to 6 factorial divided by 4 factorial into 2 factorial. Clear? So this will give you the total number of result. So that is 5 into 6 divided by 2, 2 cancelled. So that is equal to 15. Clear? So first we checked with analytical form, it got 15 possibilities. See here, it is also giving me 15 number of possibilities by the expansion of multi-nominal values. Clear? Here you have 4 possibilities to the power of 3, so that the coefficient of p to the power of 4, because see here you have 4 objects. You have 4 objects, that will give you the coefficient term. That means the coefficient of p to the power of 4 will give you the total number of the values that is possible of distribution of 4 objects among 3 persons. That is how much? 15. Clear? Okay, I think you got how to apply the values. Next, let us go for the next problem.
Okay, students. So now let us go for the second problem. Clear? That is, in how many ways the sum of upper faces of four distinct dice can be 6. See, in how many ways the sum of upper faces of four distinct dice can be 6. That means you have 4 dice. You have 4 dice and you will roll all 4 dice, and the sum of the upper face of all 4 dice must be 6. Are you getting my point? That means the sum of x1 plus x2 plus x3 plus x4 must be equal to 6. x1 is the upper face of the dice, x2 is the upper face of the second dice, x3 is the upper face of the third dice, and x4 is the upper face of the dice 4. Clear? You have 4 dice, x1, x2, x3, x4 are the upper faces of the 4 dices. If I make sum of all the 4 upper faces of the dice, it must be equal to 6. It must be equal to 6. So that these possibilities we have to check. See here, xi will be always in between 1 to the power of 6. Xi will be always in between 1 to the power of 6. And let us check the possibilities. See here, possibility is P1. On the dice, first dice, you can get 1, you can get 2, you can get 3, you can get 4, 5 and 6. If you roll the dice, what are the possibilities? From 1 to 6. On the upper face, you can get 1, you can get 2, you can get 3, you can get 4, 5 and so on, 6. Clear? So these are the possibilities of one dice. These are the possibilities of one dice. Total you have 4 dices. Total you have 4 dices. So now you have to check the expansion of this with power 4. Clear? Because the possibilities has to be written in the power, because you have to check. See here, if I check P1, next P4, next P1, complete it will be P to the power of 6. Clear? So the sum will be 6. The upper faces sum will be 6. Next possibility 2, 4. Possibility this term you can't get 0. That means this is not possible case. Here you can get 3. Here you can get 1. So this will be what? P to the power of 6. That's why the possibilities has to be written with the power. The possibilities has to be written with the power. Here P to the power of 1 plus P to the power of 2 so on to P to the power of 6 whole to the power of 4, because you have 4 dice. You have 4 dice. Here you have to check coefficient of P power 6. Coefficient of P power 6 in. Coefficient of P power 6 in, that is P to the power of 1 plus P to the power of 2 plus P to the power of 3 plus P to the power of 4, P to the power of 5, P to the power of 6 whole to the power of 4. Clear? So in this, what you can take common? You can take P1 as common. If I take P1 as common, what you are going to have? You are going to have P to the power of 4 as common term. Here you are going to have, if I take P common, it will be P to the power of 4. So on to what you are going to have? P to the power of 4, 1 plus P square plus, so on to P to the power of, so on to P to the power of 3 plus P to the power of 4 plus P to the power of 5 whole to the power of 4. Clear? Okay, if I take P to the power of 1 common from this, you are going to have P to the power of this term as 1, this is P, this is 2, this is 3, this is 4 and this is 5. That means coefficient of p to the power of 6 in this total term. Clear? So 4 is already outside, that means you have total 6, 4 already you have. Now p to the power of 4 into p to the power of 2 will give you total p to the power of 6. So this can be written as what? This can be written as p to the power of 4 into 1 divided by, see, this can be written as, this particular term can be written as p to the power of 4 into 1 plus p square plus p to the power of 3 plus so on whole to the power of 4. That means infinite terms. See, here p to the power of 7 is not possible because you can't get 7 on any face because only 6 faces will be there on the dice. But p to the power of 7 you can't get. That's why no problem. P to the power of 4, p to the power of 5, p to the power of 6, that much you have, no problem. But p to the power of 7, there is no chance. For that reason, if I take infinite series, there is also no problem. Clear? So that's why I will write this series as p to the power of 1 plus 1 plus p square plus p cube plus so on. P to the power of 4 plus p to the power of 5 plus p to the power of 6 you will get, but here no problem. P to the power of 7, if you write also no use because there will be no 7 on any face of the dice. That's why there is no use of that. That is why no problem. You can write infinite series like this. Now we want to check coefficient of p power 6 in this term. Come to here. You took p to the power of 4 common and you have written like this. Already p to the power of 4 is outside. Here you remain with what? See, p to the power of 4. Again you remain with only 2 terms. That is p to the power of 2. Now you need to check the coefficient of p to the power of 2 in this term. Before going to that, p to the power of 4 into, you can write it as 1 divided by 1 minus p whole to the power of 4. You can write it like this, 1 by 1 minus p whole to the power of 4. Now this is equal to what? P to the power of 4 into 1 minus p whole to the power of minus 4 whole to the power of minus 4. Clear? Okay. P to the power of 4 into 1 minus p to the power of minus 4. So now you have to check the coefficient of p power 6. Coefficient of p power 6 in. Coefficient of p power 6 in. Okay. See here, you have to check coefficient of p power 6 in p power of 4 1 minus p to the power of minus 4 1 power p minus 1 minus p to the power of minus 4. That means p square in 1 minus p whole to the power of minus 4. The coefficient of p square in 1 minus p whole to the power of minus 4. Because p to the power of 4 is already outside, you just check p square. Clear? So that is equal to, that is what you are going to have, 1 plus, you have to check the possibility of coefficient of p square in this term. So that is 1 minus p to the power of minus 4, that is equal to 1 plus, see, 1 plus 4c1p plus 5c2p square, 5c2p square. So your term will be what? It will be 5c2. What is 5c2 equal to? 5 factorial divided by 2 factorial into 3 factorial. If you simplify this, 4 into 5, so it will be equal to 10. It will be equal to 10. So there are total number of 10 ways of getting 4 faces sum as 6 when you roll a dice. That means you have 4 dices, you are going to roll that 4 dices. The sum of the upper faces of all 4 dices is going to be 6 for how many ways? 10 ways. It is going to be 6 for how many ways? It is going to be 6 for 10 number of ways. Clear? So that is very, very important. Clear, students? So I think you got the problem How to simplify the problem? There are 4 dices. The upper face of the 4 dices must be, the sum of the upper faces of 4 dice must be equal to 6. The possibilities are p to the power of 1, p to the power of 2, p to the power of 3, so on to p to the power of 6. There are total 4 dices to the power of 4. Clear? So now I has to check the coefficient of p to the power of 6, because the sum must be equal to 6 in this expansion. The sum of this series, before writing sum of that series, take p to the power of 4 common. It will be like this. So this term also can be written as of this form, because I already explained that p to the power of 7 not possible. So that's why if I write like this, there is no problem. It will be infinite series. Clear? So if I write the sum of this infinite series as 1 by 1 minus p by using the formula of GP, so therefore it is going to have p4 1 by 1 minus p whole to the power of 4. This will be equal to p to the power of 4 into 1 minus p to the power of minus 4. You already got p to the power of 4 outside. Now you have to check just the coefficient of p square. You check the coefficient of p square in this term, that will be 5c2. Therefore 5c2 answer is going to be 10. Therefore there are 10 number of ways for your problem. Now let us move for the next problem. Clear? Okay. So listen here. In this problem, in how many ways can 3 persons A, B, C having 6 rupees, 7 rupees and 8 rupees of 1 rupee coin donate 10 rupees collectively? That means X, Y and Z are donating the rupees in the form of 1 rupee coin. Collectively, the sum of these 3 must be equal to 10. That means person A can give X rupees, person B can give Y rupees and person C can give Z rupees. Sum of those all 3 must be equal to 10 rupees. Clear? So that means A has 6 rupees, B has 7 rupees, C has 8 rupees. Therefore, the restriction of X is from 1 to 8, restriction of Y is from 1 to 7, 1 to 6, 1 to 7 and restriction of Z is 1 to 8. Clear? So collectively X has 6 rupees, Y has 7 rupees, Z has 8 rupees. X has to donate from 1 to 6 rupees of 1 coin, Y has to donate from 1 to 7 rupees from 1 rupee coin, Z has to donate from 1 rupees to 8 rupees in the form of 1 rupee coin, so that the sum of all the 3 donations must be equal to 10. Clear? So in how many number of ways they can give total 10 rupees collectively, they are asking. Clear, students? So now let us try to find this. Clear? X plus Y plus Z must be equal to 10, so that possibility of X is p to the power of 0, 1, 2, 3, so on to how much? 10. So on to how much? 10. He can't give 10 because he has only 6 rupees. So that's why p to the power of 3 plus p to the power of 4 plus p to the power of 5 plus p to the power of 6. Clear, students? These are the 3 restrictions. Next, person Y multiplied with person Y, p to the power of 0, p to the power of 1, p to the power of 2, so on to p to the power of 7. Multiplied with p to the power of 0 plus p to the power of 1, so on to p to the power of 8. These many rupees he can donate. These are the possibilities of the donation of X, Y and Z in the form of X, Y and Z. So these are the total number of the possibilities. If I solve this, it will be in the form of 1 minus p power 7 divided by 1 minus p whole to the power of how much? They has to give 10 rupees, no problem. So 1 minus p whole to the power of 7 divided by 1 by p. This is the expansion of p naught, sum of these terms. Multiplied with the sum of this term will be how much? 1 minus p to the power of 8 divided by 1 minus p. Clear? The sum of those will be what? 1 minus p to the power of 9 divided by 1 minus p. Clear? So these are the terms, the sum of these three possibilities. So now what we have to check, see, this will be equal to 1 minus p to the power of 7 multiplied with 1 minus p to the power of 8 multiplied with 1 minus p to the power of 9, 1 minus p to the power of minus 3. Clear? So now we have to check coefficient of x to the power of 10. What we have to check? We have to check the coefficient of x to the power of 10 in this expansion. Clear, students? So let us check the coefficient of x to the power of 10 in this particular expansion. Okay. So I will remove this. Therefore, what you are going to write? Multiply these two terms. If I multiply these two terms, what you are going to have? 1 minus p to the power of 7 minus p to the power of 8. Another term is going to be equal to plus p to the power of 15 that I don't need. Clear? To solve this problem, p to the power of 15 I don't need, so I will don't write here. Into what? 1 minus p to the power of 9, 1 minus p to the power of minus 3. Okay. Again, multiplying these two terms, what you are going to have? 1 minus p to the power of 7, p to the power of 8, p to the power of 9, 1 minus p to the power of minus 3. Again, I will don't write p to the power of 8 into p to the power of 9 because it is more than 10. P to the power of 7 into p to the power of 9 I will don't write because it is again more than p to the power of 10 because I need the coefficient of p to the power of 10. So that's why I will neglect all those terms and I will write which I need. Clear? So this term can be written as what? 1 minus p to the power of minus 3. 1 plus 3c1p plus 4c2p square. This term I can get. Next, 5c3p3 I can get. Clear? Okay, see here. 1 multiplied with p to the power of 10. That is going to be the coefficient of p to the power of 10. Because here there is no p. If you have no p term, means 1 multiplied with p to the power of 10 only will give you the coefficient of p to the power of 10. Clear? This will continue like this. No problem. Clear? So 1 multiplied with coefficient of p to the power of 10, let us check. See, p to the power of 10 coefficient, p to the power of 3 is what? 3c5. Difference between these two is how much? 2. So that is p to the power of 10 will be c10 12. Are you clear? So 12c10 will be the coefficient of p to the power of 10 in this expansion. Clear? Because the difference is 2. Here this term is same. So if I write p to the power of 10, 12c10 it is going to be. Clear? Okay. So this is the coefficient of p to the power of 10 for 1 into p to the power of 10. Next, here. Again I need p to the power of 10 coefficient. So p to the power of 7 multiplied with how much? P to the power of 3. So this is p to the power of 3. Clear? If I multiply these two terms, I am going to get p to the power of 10. So that's why it will be what? Minus, as it is 5c3. It will be equal to 5c3. Next, p to the power of 8 multiplied with what? P to the power of 2. So it will be minus 4c2. Next, p to the power of 9 multiplied with what? P. So it will be minus 3c1. So these terms are the coefficient of p to the power of 10 in this particular term. Clear? So that's why this will give you the total number of the solutions. So if you simplify this, 12c10 will be what? Cancel 10 factorial, 10 factorial, 2 factorial divided by 11 into 12 divided by 2. Divided by 2, because 10 factorial, 10 factorial, 11 into 2, okay, divided by 12 minus 10 is 2, minus 5, 3 cancelled, 4 into 5 divided by 2. Sorry, divided by 2. Okay, minus 4c2. 2 factorial cancelled. 3 into 4 divided by 2. Next, 3c1. So that is 6. That will be what? 6. Clear? 3 minus 1, 2. Okay. So 3 factorial minus 2 factorial means it will be 3. 1 into 2 into 3 divided by 2 factorial, cancel 2 factorial and 2 factorial, so it will be equal to 3. Clear? Okay. Here 2 into 1, 2 into 6, 2 into 1, 2 into 2, 2, okay, 11 into 6, 66, 2 into 5, 10, minus 6, minus 3, okay. So this is 55, 10, 66 minus 10, 55, 55 minus 6, 49, 49 minus 3. So this is nothing but 47, 55, sorry, 66 minus 10, 56 minus 6, 50 minus 3, okay, it will be equal to 47. Clear, students? So the total number of the ways are 47. So the total number of the ways are 47 for donating 10 rupees by giving the sum of 3 people. Clear? Who has 6 rupees, 7 rupees and 8 rupees. So this is how you are going to use your multi-nominal theorem in your exams. Clear, students? Okay. So let us now move for the next problem. Okay, students, so now let us see how to use to find the number of solutions in equation, in the given equation. See, here you have an equation x1 plus x2 plus x3 so on to plus xr equal to n. Clear? This is one of the equation. Now you have to find the total number of the solutions in this particular equation such that x is greater than or equal to 0, such that x is greater than or equal to 0. Clear? So students, let us see here the possibilities of this x1. Possibilities of this x1 are what? P to the power of 0, P to the power of 1, P to the power of 2, so on. So this will be the possibility of x1. Clear? So like that, how many terms you have? R number of terms for every one. These are the possibilities. So multiplying that, it will be equal to p to the power of 0 plus p to the power of 1 plus p to the power of 2 plus so on to, it will be equal to the power of r. It will be equal to the power of r because you have x terms. You have to check the possibilities of all the terms. Each term has got these possibilities. So this will be equal to whole to the power of r. Whole to the power of r. Clear? Okay. So now from this you have to expand the terms. So how you are going to expand the terms? How you are going to have here your values? Let us see. Clear? So now this is equal to, this will be equal to what? This is nothing but 1 plus p1 plus p to the power of 2 plus so on to whole to the power of r. Clear? So if I expand this, you are going to have 1 by 1 minus p whole to the power of r. 1 by 1 minus p whole to the power of r. Okay. 1 by 1 minus p whole to the power of r. So that is equal to 1 minus p whole to the power of minus r. So check coefficient of x to the power of n in, coefficient of x to the power of n in 1 minus p whole to the power of minus r. What you are going to have? See. So that is 1 minus p whole to the power of minus r. If I expand, you are going to have 1 plus r into p plus r into r plus 1 divided by 2 factorial into p square plus r into r plus 1 into r plus 2 into divided by 3 factorial into p to the power of 3, clear, plus so on, like this you are going to have, clear. So write the nth term. What will be the nth term here? That is plus, see the nth term here, that is r plus 1 plus so on to r plus n minus 1, r plus n minus 1, okay, r into r plus 1 so on to r plus n minus 1 divided by what? N factorial into x to the power of n. So that is what your nth term. 1 plus r into p plus r into r plus 1 divided by 2 factorial into p square, so on to it will be r into r plus 1 so on to r plus n minus 1 divided by n factorial whole to the power, into x to the power of n. Expansion of this term. Already you know the formula of 1 minus x whole to the power of minus n. See, use this formula. Clear? 1 plus nc1 x plus n plus 1 c2 x square plus so on. You use that formula here, you are going to have the terms. Clear? So the nth term is coefficient of x to the power of n implies here x to the power of n is what? r plus 1 so on to r plus n minus 1 divided by n factorial. Clear? So this can be written as r plus n minus 1 divided by n factorial as it is into r minus 1 factorial. So this will be equal to r plus n minus 1 c r minus 1. Very, very important problem. Clear? So that means this term will give you the total number of the solutions of this particular problem. Clear? The total number of solutions of this particular problem whenever x is greater than or equal to 0. Whenever x is greater than or equal to 0, this is the total number of the solutions. That is r plus n minus 1 c r minus 1. Clear, students? Okay. So what are the total number of the solutions here? R plus n minus 1 c r minus 1. So please remember that this is the condition for this particular equation. So that total number of the solutions are r plus n minus 1 c r minus 1. We have proved here. Clear? 1 by 1 minus p whole to the power of r, 1 minus p whole to the power of minus r. So expansion of this will be written here. See, I have written here. I will choose the coefficient of x to the power of n. This is the coefficient of x to the power of n. If I simplify that, it will be r plus n minus 1 c r minus 1. So that is the total number of solution of this particular equation. Clear? Okay, students. See, now I am going to change this term. X is greater than or equal to 1. Previously here it was x is greater than or equal to 0 and we calculated the total number of the solutions which are possible. So now if x is greater than or equal to 1, here it is not 0, then what will be the total number of the solutions? Let us find. Again, if I take that, your possibilities are going to be start with p power 1, not p power 0. That is what the difference. Clear? So p power 1 plus p power 2 plus so on to whole to the power of r, whole to the power of r, because it can have any possibility greater than or equal to 1. Here it starts with p power 1, not p power 0. Clear? So now if I simplify this, I will take p to the power of r, so p power 1 as common, it will be p power r 1 p plus p square plus so on to whole to the power of r. Clear, students? So now previously we have calculated the coefficient of x to the power of n. Clear? But already p to the power of r is outside from this particular summation. So that's why p power r is outside. For that reason, we should check coefficient of x to p to the power of n minus r in this particular summation. Clear? we should check the coefficient of p to the power of n minus r in this particular summation. Clear? So first let us check what is x to the power of n coefficient, then let us calculate x to the power of n minus r. Already we have seen that coefficient of x to the power of n implies what? r plus 1, r plus 2, so on to r plus n minus 1 divided by n factorial. So this is the coefficient of x to the power of n. It can be written as what? r plus n minus 1 divided by n factorial into r minus 1 factorial. So this was the coefficient of, p to the power of n. It was the coefficient of p to the power of n. Clear? So now let us use the coefficient of p to the power of n minus r. Clear? So if I take the coefficient of p to the power of n minus r, it will be r plus n minus r minus 1 divided by, it will be n minus r factorial into r minus 1 factorial. Clear? So if I cancel the terms here, minus r and plus r, it is going to be n minus 1 factorial divided by, see this term, it is going to be n minus 1 factorial divided by n minus r factorial into r minus 1 factorial. So this term you are going to have, that is nothing but what? So this is equal to n minus 1 c r minus 1. This term can be written as n minus 1 c r minus 1. So these many number of solutions you are going to have for the equation given here whenever x is greater than or equal to 1. Whenever x is greater than or equal to 1. So very two important formulas, that is, one is n plus r minus 1 c r minus 1 and another one is n minus 1 c r minus 1. So these two formulas will give you the total number of solutions for the given equation whenever x is greater than or equal to 0 and here whenever x is greater than or equal to 1. Clear? So very important formulas for algebraic equation to find the total number of solutions. Clear? So for that reason, so this particular thing is very important. Okay students, so now let us see one of the problem on the solution of algebraic equations. Clear? Okay. The number of ordered triplets of positive integers. See, positive integers means greater than or equal to 1 case. This tells you x is greater than or equal to 1. X is greater than or equal to 1. On that note, you have to remember the formula, that is n minus 1 c r minus 1. This will fetch you the answer very quickly. Clear? But no worries, I will solve with that formula also. I will solve in your detailed form of solution. No problem. I will solve in both the ways so that it will be confirmed to you that how to use the shortcuts. Clear? So here you have three values. R value is 3, n value is 100. R value is 3, n value is 100. So possibility of x is what? P power of 1 plus p power of 2 plus so on to what? So on as it is. Again for y, p power 1, p power 2, p power 3 so on. Again for z, p power 1, p power 2, p power 3 so on. So this is the term. Clear? So here you have three terms, that's why power of 3, that is possibilities of x multiplied with possibility of, see, it will be possibility of y multiplied with possibility of z. So that's why p power of, this term of power is going to be 3. Okay. So by using this, let us solve by solution form. See, if I take p common, it will be p power 3, 1, p, p square plus so on to whole to the power of 3. So on to whole to the power of 3. P power of 3 is already outside, then this can be written as what? 1 by 1 minus p whole to the power of 3. So this implies p to the power of 3 into 1 minus p whole to the power of minus 3. That means p power of 3 is already outside. Now you have to check coefficient of p power 97, because to get the answer of total number of solutions you have to check coefficient of p power 100. You have to check the coefficient of p power 100 in this particular series. Clear? If I make a sum of this, in that you have to check coefficient of p power of 100. Already p power of 3 is outside. Again here what you have to check, the power of p, that is with 97, because already p power of 3 is outside. Multiplied with p power of 97 will give you p power of 100. So that in this particular term you have to check coefficient of p power of 97 in this term. So that is 1 minus of p power of minus 3, 1 minus p whole to the power of minus 3 equal to 1 plus 3c1p plus 3c2 p square plus 3c3 p3 plus so on, it will go on. Clear? See, the difference is how much? Here it is 3, it will be 4, it will be 5. Clear? So 1 plus 3c1 plus 4c2 plus 5c3, so on it will be. Clear? Okay. You have to check p power of 97. It will be what? See this? P power of 3, here it is 3, here it will be 97. The difference is how much? 2. So here it will be 99. Clear? So 99C 97 will fetch you the coefficient of p power of 97. This term will be multiplied with p power of 3, so that the power will be p power of 100. So therefore you are going to have this coefficient as your required answer, that is 99C 97. So that is equal to what? 99C 97 is equal to 99 factorial. This is 2 factorial into 97 factorial. Clear? So therefore 97 factorial cancel. 98 into 99 divided by 2. So this is 2 into 1, 2 into 4, 2 into 9. So therefore if I multiply this 2, it will be 4 into 8, 5, 1. Clear? 4, 8, 5, 1 will be your answer if I multiply these two. Clear, students? So here I have solved in detail. So answer is how much? 4, 8, 5, 1. So answer is 4, 8, 5, 1 for this particular question. But here it takes so much time to solve. See, we have written all this and we have simplified. Therefore the answer is 4, 8, 5, 1. But you have to solve it very quickly, means you must understand the problem. For the positive integers it is greater than or equal to 1, and you should remember this formula. See here, if you remember this formula, n minus 1 c r minus 1, n will be equal to what? 100. So 100 minus 1 c, r will be how much? 3. R will be how much? 3 minus 1. So it will be equal to 99 c2. 99 c2. So therefore this is 99 factorial divided by 2 factorial into 97 factorial. See this term, both are same. Clear? 99 factorial, 2 factorial, 97 factorial. 99 factorial, 2 factorial, 97 factorial. These two terms are going to be the same. Therefore again the answer will be equal to 4851. Again the answer will be equal to 4851. In this much only you can find the answer for this particular question. If you write this much, you will get the answer, no problem. You no need to solve all these terms. Just for the practice I have solved all the steps. Here in this single step you can get the answer. See, positive integers they have told. So that's why it will be like this. If say integers only greater than 0, the greater than or equal to 0. Greater than or equal to 0 means x is greater than or equal to 0 and integers means what? This formula will change. This formula will change to what? This formula will change to, that is, n plus r minus 1 c r minus 1. Clear? N plus r minus 1 c r minus 1 it will change. Clear? For x is greater than or equal to 0 as we discussed before. Clear? N plus r minus 1 c r minus 1. And this formula is n minus 1 c r minus 1 for x is greater than or equal to 1. This is for x is greater than or equal to 0. Here it will be how much? 100 plus r. 103. 103 minus 1. 102 c 2. This will be the answer for x is greater than or equal to 0. And this will be the answer for x is greater than or equal to 1. So that's why you must be very careful while solving this type of problems. Clear?